Okay, here we go. Theoretically, at least. Hello to everyone who's already here and anybody showing up for the recording afterwards. Sorry for starting later than I normally would. Again, I originally wasn't even going to stream tonight, but I kind of decided I had to, although not much has really happened specifically, so I figured it's about time to do one of those quote unquote educational streams again, since I haven't done one of those for a while. And I have about everything ready, it looks like. So I'm going to wait a few minutes for people to show up, but for anybody who's already here or watching the recording afterwards, we're going to jump around using this NOAA's bathymetric data world map instead of Google Earth because Google Earth causes the stream to lag out all the time. But we're going to be dabbing around the map, looking at or pointing out where specific natural resources are found. And I'll talk about and very, very crudely, poorly draw out illustrations, quote unquote, while explaining the why as to specific things being found in specific types of regions or formations. And then, obviously, there's also some uh, we do not even nearly know anywhere close to half of everything about the Earth geologically. There are a fair number of unknowns, like for some of the rarer things, why, like, very specific, why some of the, like, much rarer things very specifically have only popped up in a few places when even with the mixing that eventually occurs that gives you some different concentrations across the world, they, in theory, should have still been so diluted that we would not find such deposits, but we do. And actually, I'll probably also eventually go wandering so far off topic that the whole thing will derail. But we're going to try to keep this under an hour, or that would be preferable for both me and you. All right. Supposedly we're up to three people already, so I will drink some water and then we'll get started. And I just realized, unfortunately, I forgot. Oh, I forgot the issue that I do this. Those don't stay on the map. I forgot they're not tied to the map. I'm not a professional. I don't actually have, I don't know, whatever kind of hardcore software would link in the Epic Pen like stuff to the map on the website and would like keep it on there. They probably have a drawing tool of their own, but I'm not going to be bothered to go looking for it. I know Google Earth, I think, has a Google Earth has a drawing tool in like the premium version if you pay like 20 bucks a month or whatever, but I'm not paying that. And also, Google Earth lags the stream out all the time, anyways. Oh, all right. It's not a typical stream, so probably not going to get that many people, but it looks like four. No one's in chat though. But, anyways, we'll start with the one thing everyone probably have their minds on the most, obviously, which is oil and gas, of which there are many, many regions across the world where you find oil and gas. You find it Gulf region here. You find it in inland, uh, in Wash Basin here. You find it up through here, some bits down to here. And then down here, you got Venezuela in Wash region. You got Ecuador and northern Peru. You got offshore Guyana and Suriname there. You have the sloping shelf offshore of Brazil. You have the sort of inwash region of Argentina. And in theory, the offshore region, although the northern offshore does not seem to have uh, as much as might initially be expected, it looks like more is to be located down here on this sloping shelf offshore of Argentina and the Falklands. And then, of course, you got stuff on the sloping shelf offshore of Namibia and that offshore of Angola, Gabon, and small Congo. Yeah. You have the stuff offshore of Nigeria and onshore of Nigeria until you start getting into the uplands. You have the stuff offshore of Cote d'Ivoire and Ghana, and also stuff onshore of Ghana in this basin there, and stuff onshore of Cote d'Ivoire most likely there. You have stuff offshore, although not much has been done in Sierra Leone and Guinea. You have stuff on this offshore shelf and slope area here, and onshore Senegal, and then you come back out here. And then once you go inland, you have stuff all across here. Then you go up, you got stuff in Algeria, makes pattern like this. Libya makes pattern kind of like this. And comes back out like this, and it's all over the place there. In Egypt, it's like this, and then the offshore portions. So you might, oh, Italy had stuff onshore early on, and you had stuff in the Adriatic Sea. UK and Norway, you had all the stuff in the North Sea. And now for Norway, you have stuff offshore of their shelf in the Barents Sea or the Norwegian Sea. Russia, you have all the stuff in this wide basin here. It also extends obviously into Kazakhstan, Uzbekistan, and then Turkmenistan. So you had all that and Azerbaijan as well. Although nowadays, most of Russia's stuff is coming from up here in this region. Then obviously you have the world globally infamous Middle East, which formation kind of runs like this, sort of like this or so. Then you got all this offshore of and onshore of Thailand, Indonesia, Malaysia, all over the place. And so you might be starting to notice some particular patterns. And it's easier to notice topographical differences in some place on this map than it is with others. So for one example, we'll go into Azerbaijan. Oh, not that close, I guess. So you can kind of see here high mountains, high mountains, high mountains, high mountains, high mountains, and then gentle bit of bowl basin throughout the Caspian Sea, obviously. But you had oil and gas all throughout there. And then now a lot of Azerbaijan stuff is coming from the Caspian Sea. And then you get a kind of similar pattern over in Turkmenistan, mountains, 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 Uzbekistan. And so, nice, again, not flat, usually either gently sloping or at least just low lying basin of sorts. and it's not pictured well on the Middle East, so we have to go to a topography map. Is either of these? This one's more zoomed in, I think. And so you can see it here on the topography map. Mountains of Iran, then stretching up there, cutting through Syria, Jordan, and then a midline down Saudi Arabia there and over into Western Oman. We have this nice, massive, semi-enclosed, nearly enclosed, really low-lying, gentle sloping basin. And you start noticing the pattern, I would hope at least, that you find oil and gas most typically in basin regions. You don't find it under or inside of mountains, and you don't find it sort of dead flat in like empty nothingness, middle of nowhere, or under like the middle of the seabed. So these are the types of regions that oil forms within. And the reasons for oil's formations under, let me see if I can get this to show up. I can. Okay, we can draw on the map. So yeah, like I was saying, you see here, it cuts like this and comes up here, down here like this. And there's a bit of an interruption with some upwelling there, but primarily the formation goes, as so. So this whole fill in here is the big Middle East basin, or Arabian basin, or Persian Gulf basin, whichever you would prefer to refer to it as. And you can see similar, especially with the light green here, you can see a similar bit there on Western India, which is why so much of India's oil and gas is found there. And the reason for this being that the formation of oil and gas comes from, I'm just going to draw a bunch of random squigglies and dots, the masses of billions and billions, trillions and trillions of tons of ancient algae and phytoplankton and similar aquatic microorganisms experiencing, for one reason or another, a abrupt mass die-off and sinking to the bottom, or in some catastrophic event being washed into a particular region and to the bottom, and being put into a particular place. Again, usually at least a sort of like semi-enclosed basin, if not a slope area. We'll look at the Brazilian offshore slope in a second, but they'll get washed over with stuff, and then other stuff will come down from the surrounding, will wash down and run off from the surrounding higher elevations or mountains, and they'll get rapidly during such events buried in layers of sediment that prevent them from being consumed by other larger microorganisms or macroorganisms in the water. And then those layers of sediment that they got buried under then get buried under, over time, more layers of sediment. And so you have layer after layer after layer, and eventually have all your dead microorganisms piled under there, deep underground. And as they get put under pressure and they get heated up, uh, just do an H with, I don't know, a degree symbol for heat. They get heated up. They gradually undergo, hold on, my brain is working, various types of isolated anaerobic chemical breakdowns. And so that's why you don't find literal, actual ancient microorganisms mostly, but why you find, complex hydrocarbon components of what used to be them. And so those break down over time. And whether or not they're extractable, though, That's also then topography is not the only thing that comes into it. We talked about this with the difference, or I usually mention it a lot with the difference between the amount of oil that's been extractable in Ecuador versus Peru, because they're part of the same topography continuity, but not the same geological continuity. Because then, and you'll find this play out in some other resources as well. There's a difference in whether you can actually get it out. The basins will typically and offshore slopes will typically tell you where such things likely happened, but not necessarily immediately where it it lies in viable, accessible reservoirs. Because whether it's actually accessible and extractable depends on the type of rock layer it ultimately got trapped within. And preferably you want, we'll put S for sandstone or C for carboniferous or carboniferous rocks that are basically, I like how smiley faces are randomly forming. Rocks that if you look up pictures of them on your own, you'll find out that taking even just a magnifying glass to them reveals that you're not holding really like a solid rock per se, but you're holding a honeycomb structure basically of trillions of not even microscopic, but often even visible to your own naked eye, just really small porous holes throughout the structure. And sandstone and carbonaceous rock layers are what give this, versus if the oil gets if the oil and or gas gets like squeezed down into and through like more solid slab type stuff, then you're not going to really be able to get it. But if it, is in a S or C, I'm just going to call them so that I don't mess up the C word, uh, type of actual reservoir bearing rock, then you can actually get them out. And typically you'll get those kind of rock layers in the sediment of specific areas, especially through the Middle East and North Africa. The reservoirs end up being really good because they are, mega deserts. So all of the stuff that they got buried under, initially in like say the inwash was sand from the seafloor, and on in like the Arabian basin, for example, the stuff washing down because it's a mega desert region is also sand. So most of the layers, the sedimentary layers compacting on top of the stuff in the Middle East specifically, for example, were predominantly sand, which once it gets buried and crushed under pressure, compacts into sandstone, which, as we said, is effectively, I guess you could say it's between sand and concrete. Whereas concrete is, if you look at it, you can really tell that it's just a bunch of grains of sand with a tiny bit of paste stuck between them. Sandstone is basically take that, but visually remove the cement, remove the paste from between all those little sand grains, and they're just stuck together because tiny portions of them eventually fused and joined under pressure from being under the ground so long. So all the gaps that you might be used to seeing filled by the cement paste in when you look down at concrete and see the individual grains of it, those in sandstone are just open and the oil and gas can flow through those. Let's see, anybody show up? We got one speaking person at least. Those 6 actual people are here. Okay, so that's that type of example. And then you have you have the certain, unique types of oil form in certain places, like the heavy bitumen type stuff in the tar sands up in Alberta and under Venezuela. like the Orinoco Belt heavy oil that's all throughout under here. And what governs that formation, or uh, what governs whether you encounter that stuff or not, like up here throughout northern Alberta, is, and you'll see this with both the surface mining and the shallowness of the wells that are actually drilled to do. Here's the ground, here's the tar layer, and they pump the steam up like that. The stuff that's actually drilled and steam lifted, quote unquote, is comparatively, when you compare it to like a regular oil reservoir, it's really close to the surface. So you get stuff like that, typically the special, unique, heavy stuff, from bitumen to tar sands to kerogen, when the oil did not really go deep enough it didn't get buried deep enough under enough layers to really undergo the full chemical breakdown process, and and or and or uh, wait, hold on. Oh, which part of that should I do first? So all the basically, it has not, or actually no, because they're two different things. Yeah. So it has not been able to completely break down into the different like length hydrocarbons. Again, each of these is a bridge between two carbon atoms, and then you have really long ones like decahexane, and then the different random associated lengths of heavy chains that form up diesel, etc. It was not able to break down into all the different amounts because it did not get buried deep enough, and or with some of the stuff that's a little bit deeper, but still not that deep, like say the Orinoco Belt in Venezuela, or Orinoco Belt, sorry. There's only one eye. There's not two eyes. In that case, you had the stuff get buried, but it was in a it got buried with or into a sort of not porous, but not completely crushed rock layer that actually has subterranean microorganisms in it. And in that case, in some of those cases at least, those microorganisms will draw little bacterial blobs. Those microorganisms ate up, or will have eaten up, a lot of the shorter hydrocarbon chains. So like, the hexane, heptane, and octanes that make up gasoline, for example, or that we extract and refine into gasoline. They'll typically have eaten up a lot of those and will have left and or produced methane, draw squigglies for the methane, that either is accompanying that now heavy oil underground or leaked out up and through the ground on its own over the course of time. And what they leave down instead, left over, the stuff they didn't eat, is just the much thicker, much heavier chains. And that's the case that you see with the Orinoco Belt down in Venezuela versus the stuff up in Alberta. The tar sand stuff that's super close to the surface, so close that again, in some cases, it's physically mined. That stuff is because it never went deep enough to actually quote unquote cook all the way. And you'll typically you can typically also get a hint at what you'll find based on further differentiation of the topography. Like looking at the Gulf of Mexico here, you can see this part here, right near the shoreline, is like almost completely flat, and then this part here you see is like an actual slope. I'm not talking about over here because we haven't really done anything over there. But the flat stuff is typically you're going to end up finding a lot more natural gas there, whereas or not like not specifically only natural gas. It's just you will find a lot more natural gas there typically. Although in a lot of cases, in such areas, you do find more gas than oil. And in the actual sloping areas where it's going down like this, you will tend to stop finding a lot of gas and you will predominantly find oil. And you can see that play out in the history of the Gulf here as we got more people. These are both saints, right? Excellent. And you can see that play out for one example here. And for anybody who's new or not familiar, here's your one random introduction. Go to any video from the last 2 years and you go under it, and you will find in the description a link to a free access drive underneath the PayPal and Patreon links. You'll find this to this drive folder, which has a bunch of graphs that I make and maintain for free access for anybody, since all the official and professional looking websites are starting to put everything behind paywalls. My pay button is optional. This will always be free to access. But you can see here, if you look at the history of Gulf of Mexico gas production, you can see that most of the gas produced was in the earlier phase, in the later 1900s up to around 2000. And that's because that's predominantly when we were dealing with this area, the flat area close to shore. As we've pushed into predominantly, since the only place left is the slope further offshore, now it's gone down like that, and there's not a lot of gas left. Whereas we go back out to the oil data sets and US states down there, you can see the oil production from the Gulf of Mexico has gone up in the present day as a result of moving into the gentle slope down area here, because there's much more oil there than there is gas. So you can see there's a decent example for you of that playing out in real time, or not real time, but in over the course of time. You can see that particular pattern that I've spoken of in the past. And similarly, that's why now that they are moving offshore, and most of their offshore you can see obviously is shallow and flat. That's why almost everything that Malaysia and Indonesia are now finding, now that offshore is all they have left, is predominantly just natural gas. Whereas onshore, you can't see it too well, but onshore, a lot of Indonesia's oil was along here, and here is a slope going towards the shoreline coming off of the base of the mountains. And there is Lake Toba, which is a supervolcanic caldera. Okay, so that's the long, rambly oil and gas explanation. Now we can talk about minerals and metals. So let's see. Since we mentioned concrete and that it's typically a cement mixture binding a bunch of industrial grade sand particles together, industrial grade sand, or water worn sand, as opposed to wind worn sand or desert sand, which is too fine of a grain, too small to be used in concrete. But sand comes from weathered quartz rock in where the ocean most usually, or riverbeds, have worn it down into fine grains. Coarse, fine but coarse, not truly fine and smooth, like the wind-worn sands of the Sahara, for example. And obviously, you would assume, and assume correctly, that most such sand is found along the beaches of the world's shorelines and just offshore, for up to, depending on the region, a quarter of a mile, sometimes up to a few miles offshore, there's going to be a decent layer of seabed sand. As once you step into the water at the beach, obviously the sand doesn't instantaneously transition into like, a slab of granite or anything, or basalt, really, it would be. But you probably also, hopefully, know that we're not getting most of our sand by uh, destroying our beaches yet. Some countries are already doing that, or dredging up the seafloor. But again, some countries, Indonesia, are doing that. Most of it we've been getting from mines on shore, and those vary from place to place. In the U.S., one of the big concentrations of them is the Michigan, Wisconsin, plus these portions of Illinois, Iowa, and Minnesota area, with other areas with a lot of onshore eye sand mining, including the coastal area of Texas, areas where it exists and could be mined but is not really, are along the coastal areas of Georgia, South Carolina, and North Carolina. And then areas where uh, it was, but a lot of it has mostly been mined out, is New Jersey and Delaware. And these are just for the US example. And this is because, remember, the ocean and current bodies of water are not what has always been. At different times throughout history, the land itself has shifted, you know, west, east, up and down elevation, and the water level, the sea level, has also shifted worldwide over time. So different places were once underwater or at the edge of water. Like you can see here, actually, this roughly follows it. Uh, it doesn't stop here. It does actually continue up through Alberta. This is just where the green zone stops, but it roughly follows it. Actually, hold on. You go back here and it comes in a little more in there like that. And then we come back out, all the Appalachias. So yeah, up in here, and it would come down, Shield goes like that, or I think it's close to that river. But the inland portion of the U.S. has consistently, off and on, been part of a sea. It's been part of an semi-inland sea, or not necessarily. Sorry, an inland sea, I think, is when it's completely cut off, or almost completely cut off. But at times, the Gulf has stretched like this far up inland, and so one of its favorite places to have its shoreline and waters lap at was this region up here. And that, left a lot of sand. Obviously, when the waters were higher on New Jersey and up the shores of the Carolinas, Georgia, and when Florida was underwater, when the waters were up higher along the Texas coastline area, sand was deposited there. And then as the sea receded and life went on and different processes happened, it got buried by modest layers of sediments. That's why all said sand mines are usually really close to the surface. Like the layer of dirt, clay, and or other overburden material on top of them is usually only like from a few feet to maybe a few tens of feet. And then you can see these elsewhere, similar pattern, where you'll see Nederland, Belgium, and Deutschland, and Poland, Polska, are full of sand mines. There's sand mines all over there because that region used to be underwater as well. Let's see, we have a decent Euro topography map. Good enough. So yeah, you can see there how low-lying that area is, especially obviously the Netherlands. Probably you would hopefully be aware of because that's one of the most famous places for it. So they used to be underwater or at the former edge of the water. So a lot of high sand, industrial grade sand, got deposited there over time. And something similar happened for a lot of iron deposits. Now, there are other types of iron formations, but like a lot of, we have to fix this, go back out, took this out, draw there, delete, go back. Okay, so a lot of North American iron, for example, is mined in this area. That's where a lot of it forms or has formed. And over in China, in Zhongguo, a lot of iron is mined around here, which is, right at the mouth of a current sea and is a part of the old Dakin Basin, which used to be, an inland gulf or underwater at previous points in time. Sorry, there's iron formations in India, I believe down in this part. And in Russia and Ukraine, there's a lot of iron here. And you can kind of see a pattern, expand the Black Sea, or even have the interconnected inland sea going up the lowlands, and when the continents were shaped differently. So those iron deposits are actually the result of a lot of marine ecosystem life. I forgot like all the specific species, but there's like a specific food chain that's involved with it. And in some cases, the highly iron concentrated organisms themselves die, and different parts of them like undo themselves as they fall to the seabed or get scavenged as they fall to the seabed by microorganisms. But heavier stuff like the iron in their systems ends up falling out, sometimes in specific molecules or just as individual iron, but also along the food chain. Different things eat things and then they excrete waste. Some of that waste goes down. And throughout these processes, a lot of iron gets concentrated. Again, where uh, these specific types of ecosystems formed, most of which were as a huge chunk of sea life is near the shore in shallow, warmer waters. And so, for a while during the inland sea period, a lot of that was here, up around that area, and in those other areas I pointed out. And as the sea receded, came back in and receded time and time again, you would get depositional layers one after another over and over again and form bands. And so you get, you get the phrase banded formation. And these would in between get buried by types of sediments from things like glaciation or regular river water runoff and such. And so over time, That's where you get a lot of the more concentrated iron formations that we mine. And let's see, what else can we touch on before switching over to most of the metals? Aluminum. Aluminum is also, it occurs in something called bauxite ore, but aluminum or bauxite ore forms is also heavily related to the sea and interactions with water, as you find where you end up finding bauxite, whatever type or grade of it, like the lower grades in the U.S. versus the epically amazing high concentration grades down over there in Australia or down in Brazil. You in the U.S., a lot of it's here and was also here. Those were the two main bauxite areas. But you'll also have heard me mention a few times, probably, that throughout here and even up here, we could also, I know I've mentioned this before, we could also get some degree of aluminum just at higher cost out of a number of large clay formations. And if you're putting two and two together, you probably got it right. A lot of bauxite or aluminum ore comes from the intrusion or interaction of seawater with clay formations, usually close to a coast, or in some cases, close to where there used to be a coast, and different processes of the interaction of that water intruding in ends up drawing out aluminum from that clay, and it comes out and then gets placed into other surrounding rock layers, interacts with other minerals, and then forms the actual bauxite ore in a higher concentration of aluminum than the aluminum occurred in the clay itself. As a lot of clay, a lot of its composition is various combinations of aluminum, silica, with with a lot of other things like a few carbon and oxygen and like chlorine atoms and stuff added on. So that's why those were found there, for example, and that's why you get a lot of bauxite along the rivers in Brazil. Hello, stream. Okay, we're okay. That's why there is so much of it in Guinea, and so much of it around different portions of the coastline of Australia, especially northeastern Australia, because that's where there's a lot of clay formations, or were in some cases. Ah, all right, now when you start moving into some other things, other metals outside of those two, once you get into things you might more immediately think of, like gold and silver, or copper, or other things like that, or any of the other metals, really. Once you get into those, you'll start to notice a pattern if you think about where are a lot of those mined. You'll know because I've talked about back up home in Alaska, in Fairbanks, Alaska, where I used to live before my exile began after 2020 happened. But I can't return home until I have an income of at least $800 a month or more. And right now, I average I don't know, like 300 sometimes. But we got a lot up there. You Canadians will know there's lots over the Yukons and down here in BC. Then in the US, a lot of it's in the Rockies there, especially in Nevada and Arizona. Whole bunch of silver and copper in Mexico, most people are probably aware of. And then a whole bunch of copper, silver, and other things, lead, zinc, and whatever, mined in Peru and then through Chile as well. And then mined in the uplands, the highlands of Brazil. Mined in the upwelling area and highlands of South Africa. Mined in southeastern Congo. Mined in, although Poland's the only one really still doing it because a lot of European countries have turned anti-mining. Mined in the mountains or around the base of the mountains in southern Poland. Make sure I'm getting the location right, up and down the mountains and random highland regions in Russia, like around here. And this isn't showing the land topography all that well, but I think around like here as well. A lot in Mongolia, a lot in China in the south or more mid-south region. A whole bunch of stuff in northern interior Myanmar. And then a whole bunch of stuff, obviously, everyone knows across Indonesia. So you might be probably noticing a pattern there. Whereas the other stuff was usually in low-lying areas, in basins, in along shorelines. A lot of excluding, iron and aluminum. A lot of the metals you hopefully notice seem to be concentrated in mountains or around mountains at least. And that is because of a number of different geological processes. So, mountains get, big up push of land from where plates are usually meeting and smashing together, thus causing them to push up a bunch of stuff. Or in the case of highland or upland regions, like, say, those Brazil, some of the stuff in Mauritania, where the Rakat structure is, some of the stuff in the middle of Russia, some of that stuff is more because of temporary or long-term mantle activity that was just sort of upwelling and pushing stuff up on like a wide scale so that you get more of a just a kind of generic upthrust of the land as opposed to like an actual full upward push of a mountain range. So that process results in mountains and highland and upland regions. And as one part of the process, again, one part is as these form, as you get the mountains forming, the material is being pushed up. Now, remember, over time, everyone only thinks of solid material as being standstill, but even solid material over time, if you look at it, we're not even talking about the mantle being semi-solid magma. We're talking about actual mountains and rocks. Over time, the material inside will start to weigh out roughly, like really roughly. It won't settle out into literal layers of this element that weighs this number, this element that weighs this number, but you will see the heavier things start to stick or fall through the process and stick closer down to the bottom areas. And so once you get that, and also in the upwelling areas where, like in the middle of Russia, for example, where a lot of those upwellings are lingering results from the Siberian trap eruptions of long ago. In a lot of those cases, where it was like magma that heaped on itself over and over again in different formations and everything over time. Magma is actually semi-solid liquid, or sorry, it's semi-solid rock. It's moving really viscously and really slowly uh, in a sort of liquid-esque behavior, but just over, really molasses time frame. So it's even easier in magma. Let's see, we'll draw. Here's the ground. There's the magma blob, and then blah 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 blah, and then fire on top. Uh, in the magma, since it's even at a slow pace, it's behaving kind of liquidy. It's even easier for that weighted settle out to happen, where heavier stuff, like say, precious metals, for example, will and then lead and copper and etc. will end up over time more towards the bottom. And whether you have just sort of a highland or upland formation, or whether you have a mountain itself, apart from that process, you then remember, we'll draw a rain cloud, for example. You then also, over time, get the weathering process of either of those formations, which then erodes and washes a lot of the stuff out. But the stuff will, sink to the bottom of the flowing erosion pattern, usually water, and so it won't go very far. And eventually, it starts to collect more along typically specific portions of ground or geology that it's a little bit more attracted to or interactive with. And so then it'll stick around those after being washed out, and you'll get you'll start getting your proverbial, or it will start sticking around those in a deposition, from which you then get your mineral deposit that you then mine later on. And none of these are literal like Oblivion or Skyrim-esque like giant boulders of silver or gold, for example. They're concentrations. Sometimes sometimes they're just enough to where like you can see like golden glimmer on the rocks. In that case, it's a vein when it becomes visible to the naked eye. But usually it's just it'll just be like the surrounding rock has a generic soil or crust concentration of whatever mineral, say gold, for example, Au, aurum. It'll have, you know, like 1 part per million gold. But then you'll have this over here where there's like double digits parts per million gold. Or you'll have epic epic gold deposit that was found a few years ago in Fiji, in on the slopes of one of the volcanoes. That one was one of the highest ever, where it has over 500 ppm concentration of gold in that particular deposit. And then instead of parts per million, when you're dealing with things like copper or Cu for its elemental name, then because that is a much more abundant metal and will accumulate much more readily. You're just going to be dealing with percentages. So, say like 1% copper up to 4% copper if you're dealing with like a fantasy wonder mine. Whereas like the surrounding dirt and rock will be, you know, well below 1%, but nowhere near as low as obviously like gold, whatever gold's concentration is in the surrounding rocks. So that's the generality of how that process occurs and why. But we do have some anomalies. We do have some anomalies where, for example, most of the world's tin is right around here and doesn't really show up anywhere else in any meaningful levels. And in some cases, when once you're dealing with stuff that's not that abundant, and that's sort of falling outside the rules, there are other things to consider. Like for one, there's a lot less of some things within Earth than others, and within the mantle, you have the different patterns, convection currents of the magmatic semi-solid rock over time. It'll color in the core here. Stuff that gets closer to the core obviously gets hotter, so then it comes back up, comes near the crust, cools back down, comes and sinks back down like that. Except for some parts of it will actually well up through the crust, whether meeting points of the meeting points of the different continental plates, or at just random upwelling sites like the old Siberian traps back in their heyday, or the I forgot the name of it, like Blomfeld or whatever formation in northeastern South Africa, where most of the world's platinum group metals are. But you'll see a pattern like this depicted in a lot of textbooks, but the interior of the Earth is not just a perfectly flower looking connection of all these same and or equal convection currents. If you look up like a 3D estimated map from different earthquake soundings that we've managed to get through the Earth over time, you've probably seen. I can't draw 3D stuff, obviously, but you'll probably see, there's all these weird higher density blobs near the core, and then up in the middle of the mantle, we found like, oh, there's this like lower density blob here, and it's like moving in this direction. And in reality, the convection currents aren't just doing these up and down loops. They're actually like all convoluted and like tied together with each other in these weird undulating sea serpent currents. And over the course of like all that kind of stuff playing out, that we, no matter how much RAM NVIDIA buys up, even they would never be able to give you the amount of computational power to simulate all of the Earth's history of all of those different variables. Over that kind of time, and all of those different things interacting, a lot of which we also don't even really completely understand yet, you would eventually get like weird concentrations of things to where like somehow a whole bunch of the tin down there in that magma would just kind of eventually end up in like one segment in one set of loops, more so than any of the others. And those would end up being the ones that come up through the processes along Indonesia and Myanmar and Thailand there. And similar other things have happened with different otherwise seemingly random concentrations around the world, where you got like the most of the platinum being there, and over on the border of Montana and British Columbia in North America. So there are a few unpredictable randos out there, but the majority of the metal formations fall into the general pattern that I described before those ones, with also the exception of iron and aluminum that follow the patterns that I described before those ones. Ah, and then a few other things. Let me think. Helium. So helium, most of the helium we get comes from deep within the earth. There's some untold, unfathomable quantity of it mixed throughout the mantle and the deep portions of the crust. And at that point, where you find helium in reservoirs underground is going to just be tied to where it could get up, where the, or technically, helium can slip through basically anything, like in between the molecular atomic gaps of anything. This is why, even in like big storage containers, like super vacuum sealed storage containers for it, helium will still leak out through the container no matter what. It actually can go through the walls at a very, very marginal rate. But the fact is, it actually can, while basically any other gas can't do that. But helium is just really super unique. It's one of my favorite elements, tie between helium and tungsten for my favorite. But so over the crust itself, helium in general can get up. It can wiggle its way up overall, and over the seabed, over the land. There's helium inevitably leaking up all over the place at undetectable levels, but in some areas, coming up from, we'll draw cracks here, coming up from the mantle and from the deeper crust, there's some places, and we're not talking about near surface, this time we're talking about the mid and deeper crust. There's some places where, based on the geological layers, the rock composition in those portions of the crust in some locations, like, say, under Oklahoma and Kansas, for example, where a lot of the world's helium is extracted today, the deeper and middle portions of the crust just happen to be quote unquote cracked a lot better. They're a lot more permeable. So, way more helium is able to make its way up, and it finds its way into various underground reservoir esque areas, some of which even being natural gas fields like the Hugoton field that gets a lot of helium accompanying the gas. And so you have areas like that area under the U.S. plains in the middle there. You have the middle area underneath Qatar and offshore of Iran. Basically, the mid and deeper crust underneath the Pars natural gas field under the seabed of the Persian Gulf is another one of those seepage areas that's just really porous. Tanzania, down there near the bottom of Lake Victoria, there is apparently another such area because in recent testing over the last few years, geologists have found high concentrations of helium under that area, not accompanying any reservoirs of oil or gas. It's just the helium there by itself, which also does occur sometimes. That does occur in a few places. Uh, and some locations within Russia as well. I forgot which ones. but also another location similar to the Lake Victoria, Tanzania situation is actually Poland. Uh, Deep under Poland, in the mid and deep crust underneath Poland, there was apparently permeability enough for much higher concentrations of helium than normal to leak up. And so helium is actually extracted from the ground in Poland. Let me drink some more water. My throat is dying. Did we get anything else from anybody? Nope. And no. And both stayed same. And what was this? What was I doing here? That looks like what, 15 minutes ago? What made everybody leave 15 minutes ago? You can find such maps. It's just that some of them are now behind paywalls, and others are not really good. Like they're at really low resolution for some reason, and or they're just like artistically horribly conceived, and they kind of just like throw everything on top of each other. Is oh, that's when it started lagging. Did it lag for that long? And a lot of them just like throw everything on top of each other. I'm trying to think. I know I found a few over time that were kind of good, but you're not going to get like you're usually not going to find an everything stack. Like you'll tend to you'll tend to find ones that are a bit more several ones that are more focused, like ones specifically that will show you oil and gas. Others that will show you specifically precious metals. The only ones that I've seen that uh, sh- were like everything maps were really childish ones where it didn't show you like formations or even precise locations. It just had, cartoony pictures of like for gold. It literally on the to show that the US and Canada both have gold formations on both of them in the middle of the country next to the names. It literally just had two gold coins with the dollar symbol, and again, just next to the name, it had two drops of oil in the on like a barrel formation. So if I find an actual decent one, I'll like link that in a post on the channel or something. Uh, I think that's I think that's pretty much probably the extent of everything. Or if I maybe if I can find a big enough map for where I deem it worthwhile, I might make another folder in the ever-growing list of infinite folders and subfolders in the Google Drive with different maps uh, highlighting different regions of stuff. Or at least I try the best I could. Like here, the docking basin and coastline and this whole area, these mountains and everything. That has a bit of everything, although the oil and the gas are largely depleted at this point. But there's also iron, there's zinc and copper and all kinds of other metals and stuff. That's actually the reason why. Uh, and I mean, proximity helps. Obviously, that made it easy, but that's a huge chunk of the reason why the whole at the time Manchuria, now I'm just referring to it as the Dakin Basin and mountains that surround said basin. That's why that area was the first invasion target of Japan in World War II, because that had enough of everything they needed to start doing conquest and genocide for the sake of doing conquest and genocide. All right. Sorry that everybody started showing up right around when everything's about to come to an end at this point. Because yeah, I think that's pretty much it. I'm probably forgetting about like a number of things that I would have spoken of otherwise. Uh, but oh wait, yeah. Uh, Rare earths. A lot of the rare earths you find in this region here, some down here, some in, I think it's here, and then there's a bunch in the middle of Australia here, dead center. There's a number in the mixed in to some of the layers of clay and sandstone underneath the surface, the initial surface layer of sand and dirt in along the coast of Somalia, and obviously there's the something something pass deposit in Southern California. Rare earths are kind of more scattered throughout the crust, throughout the dirts, and etc. When you end up getting like a highly concentrated version of them, it predominantly it predominantly comes because uh, they rock layers like containing them were gradually pushed up through time up to and around a layer of specific types of clay. It's I'm just going to refer to it as black clay slash blue clay because that's kind of what it looks like when China digs it up in Inner Mongolia. But that's usually it, and it's not normal clay. It's not the regular aluminum silica clay. It's a different kind of clay that I think is based on a different uh, base metal that has similar properties to clay, so it's still categorized as it, but it is more reactive and attractive than regular clay is, and specifically to most of the elements that fall into the category of rare earths and strategics. And as those get pressed up into there, and eventually, usually as well, some there's some sort of underground water flow, hydro hydrothermal activity, maybe just aquifers going up and down, aquifer levels going up and down, dipping into the rare earth rock and then bringing it up through those. The more reactive ionic clay attracts and absorbs a lot of the rare earths over time with each pass that the water washing through it brings. And it doesn't let go of them. It keeps a hold of them. So each time it accumulates more and more. And that's where you eventually get concentrations of it. And then in some places, like the Somalia example, the clay layer got either compressed or wasn't very thick to begin with, and has also kind of been intruded upon both by seawater and by other rocks and is kind of fractured and is a bit busted up and mixed in with the sandstone and such. Okay, now that should probably be everything. Uh, I mean, given its geological and topographical formation, yeah, it probably does, but uh, not even Russia really touches it because it's, kind of a bit out there and it's also a bit difficult to work with climate-wise. There is oil and gas in the Sea of Okhotsk because, you can kind of see obviously that it's a semi-enclosed basin, which is usually the best place to find oil and gas. Uh, there there are a few mines that know of on the Kamchatka Peninsula for various different metals, from gold and silver to zinc and lead, and accompanying copper, the normal stuff you would expect to find at mountain ranges. Uh, I don't know if there's anything else specifically there, but even the stuff that is there is not really being heavily dug into because again, it's Kamchatka. Like why would they bother doing that when they have, accessible stuff here, down the Urals and in the Siberian upland portions, which are already difficult to work with, but at least they're, not this. They're not like real edge of the world. All right, that should be it then, unless anything else comes up. I'll wait and see for 20 or 30 seconds, 'cause that's the usual delay time. Ah, so sorry to anyone who showed up late and somehow accidentally didn't read the title and thought this was going to be a normal event update stream. That will come probably since not that much has actually happened. I'll probably just do the one on Thursday and have this count as the other stream or secondary stream for this week. All right, that's it. I'll see everybody around next time, and the natural gas production levels update video should be up tonight or tomorrow. I already uploaded the other ones that everybody was waiting on.